Okay, well, I think most people have sort of trickled in by now, so we might get started. Just a big thank you and welcome to the Earth Systems and Climate Change Science Hub's Science Webinar series. This webinar today will be provided by Professor Nathan Bindoff from the University of Tasmania. Nathan's webinar will be on the IPCC processes and our changing oceans, ecosystems and human communities. Just before I introduce Nathan, just a bit of housekeeping. Most of you, I've said this before, but most of you will realise that you are all muted, and also most of the videos have been turned off. This is just to reduce feedback and distraction. However, if you do have any issues or throughout the presentation, if you'd like to ask questions of Nathan, there is a chat box function in Zoom that you can put your questions in. We'd love to have around about 15-20 minutes of questions at the end, so really keen to hear any of your questions or comments about the presentation. So please do throughout look up that chat box. I've written a few welcome messages there already, and please put your questions there, and at the end of the webinar I'll facilitate a sort of question and answer session by reading through those questions and asking Nathan to respond. So Professor Nathan Bindoff is a researcher at the University of Tasmania, and he's had a long and fruitful career in oceans and climate change science, beginning with some of the first papers and methods for analysing the changed and changing states of our oceans. So some of his research highlights have been the discovery of the acceleration of the water cycle from ocean salinity measurements due to climate change, making some of the first estimates of the high melt rates of the Antarctic ice sheet by the oceans, and writing some of the first papers on the human influence on the oceans. So Nathan's has some really important leadership roles in the IPCC assessment reports, the last 3 reports, and he's also a deputy leader of the Hub's Project 2.5 for Changing Oceans and Australia's Future Climate. So without further ado, I'll pass over to Nathan to start. And as mentioned before, if there's any issues or questions, please write them in the chat box. So over to you, Nathan.
Thank you very much. Thank you very much, Sonia. We just have a little bit of feedback there, Sonia. Is that better? Thank you very much, Sonia. Yes, thank you everyone for coming to today's webinar. What I'm going to do is just talk about 2 things. I'm going to talk a little bit about the IPCC and how the Intergovernmental Panel on Climate Change works to kind of deliver up the latest assessments of climate change research on behalf of all of the nations of the world. It's a joint United Nations and World Meteorological Organization activity. And then the second thing I'm going to do is I'm going to talk a little bit about the special report on the oceans and cryosphere in a changing climate. So that's one of the latest reports that the IPCC will do, and I'm part of that process. I can't actually specifically talk about IPCC special report on oceans and climate change, but I can talk a little bit about the science that underlies it, and I'll do that in the second half, and then I'll finish up with a bit of a summary. The Intergovernmental Panel on Climate Change regularly publishes assessments around climate change. And I'll go a little bit into the history, but this is actually the last round of assessments. In the 5th assessment round, there was an assessment of the climate change science around physical science. There was an assessment around impacts, adaptation, and vulnerabilities across the world. And then there's a 3rd working group which really deals with the underlying issue, which is the emissions and the mitigations of emissions for the mitigation of climate change. And these 3 assessment reports are actually synthesized up in a synthesis report, and that was published in 2014. And those collectively, those 4 reports were the key reports that came out of what we call the 5th assessment report. And we're now entered into the 6th assessment cycle, and the first report has actually just been released in October 2019. And this particular report was around global warming of 1.5 degrees. That report was actually commissioned by the United Nations Framework Convention on Climate Change to address this question of whether the 2-degree limit that was established for the 4th assessment report was actually the right one, and whether there would be some real benefits in actually mitigating more strongly for a 1.5 rather than 2-degree limit. So what does IPCC really do? What it's really about is taking the experts, expert scientists in climate change from all around the world, assembling them together and creating these assessment reports. So there's a suite of authors, and it's especially rigorous. And I'll talk a little bit about that level of rigor. But as a consequence, we have expert reviewers and we have review editors to make sure that the commentary provided by those expert reviewers really is reflected into the text of those assessments. So on the right-hand side here, you can see there's a very strong scientific research community input into the assessment process. And that assessment process, because it's a joint thing between the World Meteorological Organization and the United Nations Environment Programme, interacts with the 495 member states of the United Nations. So every nation in the world is actually part of the Intergovernmental Panel. And that Intergovernmental Panel has, in each country, a set of national focal points. Australia has one of those, but so does every other country. And that's part of the engagement of the United Nations with each of its member states. And so these reports that are actually created by the IPCC sit right here in the middle between the authors and the expert reviewers and the review editors and the governments themselves over on the left-hand side. And in this science policy interface, you get basically 3 reports. You get what we call a working group 1, which is about the physical science. We have working group 2, which of course, understanding that there are consequences of climate change, there'll be impacts, and those impacts either need to be adapted to or actually in some form or other responded to. And then there's the identification of the vulnerable communities as well. And then there's the 3rd working group, which is actually entirely around how you would mitigate the underlying problem of human-induced climate change on the Earth. And then finally, there's every nation basically actually undertakes a program of accounting of greenhouse gas inventories on a per nation basis. And this is a central part both of the Kyoto Protocol and also of the new Paris Agreement. And so there's a task force specifically around the national greenhouse gas inventories. So that sort of summarises up the IPCC as a interface sitting between the experts in the research and the governments on the left-hand side. And the task, of course, for IPCC is not to actually underdo or commission new research. It's really all about the assessment of the burgeoning, of the growing, of the exponential growth of literature that allows a sort of comprehensive and transparent evidence-based assessment of all of the factors, not just the science, which I've talked primarily about in the past, but also some of the technical and even the socio-economic kinds of information you need to understand the risks of human-induced climate change and the impacts of that, and whether there are options actually to adapt to the climate change and also to mitigate the emissions. Now, that task is central to the IPCC, but IPCC reports themselves don't actually have any agenda. They're really neutral with respect to policy, and my past experience at some of the plenary sessions of IPCC is when you get into most trouble, is when you actually are perceived to be not neutral with respect to policy. And so this is a key element of the IPCC process, that we are neutral with respect to policy, and that we kind of deal entirely objectively with the scientific and the technical and socio-economic factors of particular policies. So IPCC, if you like, is policy relevant, but not policy prescriptive. Now, the beautiful thing about the IPCC reports and the way it's been structured and set up means that basically in each of these assessment rounds, the delivery of the assessments around the climate change across those three working groups means that the conference of the parties and the negotiations that go on afterwards are properly informed by the latest research, which has been distilled down into something that can actually be understood by policymakers without having to read the enormous literature that goes with each of the reports. And it's that interaction between the development of the assessments and also the negotiations that go around the United Nations Framework Convention on Climate Change, which gives these assessment reports the importance and influence that they have. And it's really because they're geared up to deliver assessments of climate change on behalf of governments. So this particular slide shows the IPCC. It was jointly established by the WMO and UNEP in 1988. So this is the 30th anniversary of IPCC. Now, it turned out that the first assessment report was produced in 1990, and that actually became that report had enough information, enough urgency about it for actually the United Nations to agree to the establishment of the United Nations Framework Convention on Climate Change. So that first assessment report led to the establishment of the UNFCCC. In 1995, the second assessment report was actually released, and that was the one that talked about a discernible evidence for human influence in the global climate system. And that report actually was the forerunner through the various year on, year out Conference of the Party meetings that led to the Kyoto Protocol and its establishment. That protocol actually came into force during this period between the second and third assessment reports. The third assessment report actually led to the understanding that not only were there going to be significant climate impacts, but actually also that we now needed to adapt to the amount of climate change that we had actually committed to by virtue of releasing greenhouse gases into the atmosphere. The fourth assessment report, which is actually the report that led to IPCC, along with Al Gore being awarded the Nobel Peace Prize. Nobel Peace Prize I like because it was for peace, not for clever thinking. And it's the synthesis report that came out of that fourth assessment, which actually led to the establishment of the 2-degree limit for dangerous climate change. And then in the fifth cycle, the fifth assessment report, actually out of that, we actually led to the Paris Agreement. And the Paris Agreement actually has relatively strong aspirations across all nations to a kind of a 3 to 4 degree temperature change, but actually also led through the UNFCCC to the development of the special report on 1.5 degrees, and also to the special report on oceans and cryosphere in a changing climate, and a similar report over land surfaces, the special report on climate change over land. And in the sixth assessment cycle, which is the one we're currently involved in and will conclude in 2022, is just in time for actually the global stocktake and review of carbon emissions and the promises that were made in the Paris Agreement. That was the 5-year plan. So just to summarise, what IPCC has done is it's worked very closely with the development of the negotiations around the United Nations Framework Convention on Climate Change. And then it's delivered reports which have actually led into the new thinking, new points in the negotiations around both emissions and adaptation policy across the world. And here is just a timeline of the current round of the 6th assessment reports. And the report that I'm involved in this round is the Oceans and Cryosphere report, which will have its release in September of 2019. One of the things that people, because of the nature of climate change science, one of the things that's actually central to climate change research is its particularly collaborative nature. And the IPCC process encourages collaboration by the very fact that we're in the business of making assessments of all the climate change research that's available. And Jeffrey Sachs, I like this quote, and so I've used it many times, but Jeffrey Sachs, who really won a real Nobel Prize, says the IPCC is a remarkable example of mobilising expert analysis to inform policymakers. And he's clearly the positivist here. Our own Australian of the Year, Tim Flannery, says IPCC assessments are dull as dishwater. And I actually have to say that they're both right. IPCC is remarkable for mobilising expert analysis, and I'll demonstrate that to you in a moment. But he's also right that there's a complicated language that sometimes goes with these assessments that makes them a little bit dull, even though they're being effective and in each assessment cycle have played a critical part in the negotiations around carbon emissions. So let me give you kind of a specific example. And this specific example is actually the development of the 5th assessment, Working Group 1, Climate Change, the Physical Science Basis. So this was the last round of the IPCC process. And you can see here that it's basically a 5-year project. The original outline was approved in an IPCC plenary session with the participation of all the governments in 2009. In 2010, 260 people were basically selected to act as authors or review editors of a document that was designed to be 14 chapters long and have, in addition to the chapters, the research around climate change, an atlas of regional projections. Now, in that process of writing this 1 million word document, there were 3 rounds of peer review, and total across the entire volume was 9,000. So across the total volume, there were 55,000 different review comments with participation of about 1,100 experts who were analysing the words and suggesting changes. Nearly anyone is actually allowed to be a review editor, a reviewer of these IPCC volumes, so it's relatively open. In those 3 rounds, we actually have to respond to all of the comments, and so it's much more thorough than perhaps traditional peer-reviewed papers. In the process, we actually reviewed something like just under 10,000 peer-reviewed papers. There's no one in the world who can actually read 10,000 papers and assess them. And this is why we need teams of like 250 people leading the writing of the assessment reports. And it just illustrates the enormity of the literature that underlines these assessment reports and the difficulty for people in public life, in governments, to actually understand the relevant messages that come out of that peer-reviewed search. It turns out that from the 1 million words, that we were able to distill it down for a key document of about just 14,000 words. So the summary for policymakers, which is the central part of these working group reports, are relatively short. And in fact, if you distill it down, there are really just 19, in this particular volume, just 19 key headlines, and you can actually condense them down to 2 A4 pages. So there's an enormous power in this document. If you trust the underlying process, it has an extraordinary capacity to actually distill all of the current research down to a relatively short document that nearly anybody can read, and certainly anyone can read the 19 headlines condensed onto 2 pages. And the next slide just illustrates perhaps the point that Jeffrey Sachs was making. This is really a team effort across the IPCC. This is actually the chapter team for the detection and attribution chapter as part of the 5th round. And in the special report on oceans and cryosphere and a changing climate, we have a similar group of 15 people who are there to deliver up the chapter. And this is very much a collaboration with the involvement of each of the members. In addition to those 15 lead authors I showed you, and this is what a chapter would look like, we actually had 3 review editors. So why are there review editors on each of these chapters? These review editors are there to make sure that actually the commentary provided by the reviewers is actually listened to, and there are changes, substantial changes made to the text in response to them. It turns out that actually the review comments themselves are published and they can be analysed after the fact. Not only do we have 3 review editors, we actually have 58 contributing authors. These are shown here, and those contributing authors will help in any number of ways, testing the words, testing the logic, making sure that our figures are up to scratch, and perhaps just ground truthing some of the writings that are involved. So if you look at it, in this single chapter, we have something like 75, nearly 80 people involved in its development. There are 3 rounds of reviews. There's a first order draft, a second order draft, and a third order draft. And in that assessment, we had roughly 4,000 comments across those 3 rounds of reviews. Amazingly, I wrote a total of 10,000 emails in response and the development of that particular chapter. And if you work it out across the whole of the Working Group 1 report, there are roughly 250 authors, but there are probably nearly another 600 contributing authors in total. And it turns out that in that last assessment report, which was perhaps too long, there were 214 pages of draft text. There were just over 1,200 scientific figures and tables. It turns into a colossal effort. But the key part is actually development of the summary for policymakers. And the summary for policymakers is actually tested in the final plenary session. In this case, these are the Australian delegates. So from Australia, there's 3 of them in this case, and there were some coordinating lead authors there as well to support the science part of the activity. It turned out actually most countries had more than 3 delegates, and so at the final plenary session where everything is agreed to, there would have been about 400 people sitting out in front of the panel waiting to agree on the text itself that came out of this report. So this is the opening plenary session. These reports are taken very seriously. This was in Stockholm. This is the Minister of the Swedish federal government. Here is Thomas Stocker, Dahin Kerr, the 2 co-chairs of the Working Group 1, Rajendra Pachauri, and the then Secretary of IPCC, Christie. And what we do in this session is actually go through the procedure line by line. And it's line by line of all the text, all the tables, and every part of the figures. And the strategy or the game is that if it's not agreed by any of the nations, and this is done by consensus, if it's not agreed, then that text is left out. So it's absolutely critical that over the 4 days of the meeting that we actually get through all of the text. Otherwise, you might miss out on the key parts of the text. And here we are on the end of day 3. We've got 1 day to go. There's a total of 20% of the text being agreed, and we're through 70% of the time. And the response to this difficulty is to actually schedule a few extra sessions. We had an extra session that night. We worked all day Thursday, starting at 8 a.m. And some of us put in 24-hour days, and some of us didn't quite work all the time. But amazingly, we actually got through to completion of the entire amount of text. The final plenary session actually agreed to the final bit of text and the whole of the summary of policymakers at 5 a.m. on the Friday morning, before the press release began and press conference began, as shown here, at 9 a.m. And at this point, Thomas Stocker had been awake for about 2 days. So what did we actually say out of that 4th assessment report? And this is pretty much what's going into many aspects of the special report on oceans and cryosphere. We said that CO2 concentrations have been going up inexorably. In fact, we've crossed the 400 parts per million. And since I was born in the 1960s, we've risen from 310 parts per million. It's the highest levels we've had in 1,800,000 years. It's just unprecedented. The oceans have warmed, and they've warmed everywhere from the ocean observations, pretty much everywhere, with a greater temperature rises in the northern hemisphere, with weaker temperature rises in the southern hemisphere. But actually, it turns out the science shows us that there's more energy uptake in the southern hemisphere than there is in the northern hemisphere, really because there's much more ocean in the southern hemisphere than the northern hemisphere. And we don't just take a single line of evidence, we actually take many lines of evidence. The Arctic sea ice extent is plummeting. The oceans have been rising very clearly since the 1970s and are continuing to rise in the total heat content stored. In fact, the estimates are that about 90 to 95% of the total energy that's trapped in the Earth's atmosphere through greenhouse gases ends up in the ocean, slowing down the surface warming. Sea level, because the oceans are taking up heat, they actually expand thermally, and sea level is rising. It's currently rising at roughly 3.4 millimetres per year over the last decade. The contributions from Antarctica and Greenland are growing, so that to the extent that glaciers plus thermal expansion is about 75%, with a 25% contributions from the 2 ice sheets. Because the partial pressure of CO2 is going up in the surface ocean, the ocean pH is actually declining. That is to say that the ocean acidity is actually increasing by about 30%. And if you take all of these lines of evidence, in the observations, warming, you would conclude warming in the climate system is unequivocal. But to conclude that warming in the climate system is unequivocal doesn't prove that it was humans that did it. And the way we test that is through the use of our climate-coupled ocean atmosphere models. And if you force those models with just natural forcings, and so by natural forcings, I mean volcanic eruptions, I mean variations in solar radiation, and I mean the natural internal variations that occur in those models. If you force the models with just those things, so these are really the competing hypotheses, you would actually see a slight decline in temperature since the 1960s, caused by a succession of very strong volcanic eruptions and certain aspects of the solar cycle. But if you add in the anthropogenic component of greenhouse gases and aerosols into these same models, what you find is that the temperature change goes up in a way that's actually consistent with the observations shown in the black line here. And what this is really showing us is that that you cannot explain the observations with the competing idea that it's due to solar variation, or it's due to volcanic eruptions, or it's due to internal variations. And the conclusion must be that for the global average temperature of this at the surface of the Earth, you must use both the natural and anthropogenic forcings to explain the large temperature rises since the 1960s. And that was the conclusion we came to in the fourth assessment report, not the fifth. But you can see actually, since that fourth assessment report, you can actually examine across a greater suite of components. And this figure here is trying to sum up all of those emerging anthropogenic signals in the global land surface, in land and ocean surface, in the heat content of the global oceans. And it's not just at global scales that we can see this emerging anthropogenic signal. You can see it at continental scales, like over Australia, Asia, Europe, Africa, North America, South America, and in the oceans themselves. And this led, in the fifth assessment report, to conclude that it's extremely likely that human influence was the dominant cause of the observed warming since the mid-20th century. And just to put it bluntly, human influence on the climate system is clear. So we're not only are we saying that the ocean and the Earth system have changed unequivocally, we're saying actually not only have they changed unequivocally, humans have been driving it. And as a consequence of that, we have a little more faith in our projections. And here is the projection of the global average temperature going from the historical record through to the present and out to 2100 for a high emission scenario and a low emission scenario. And even this low emission scenario exceeds the 1.5 degree pre-industrial temperature. And some of the models would actually show a temperature higher than 2 degrees, the dangerous temperature change limit defined by the United Nations Framework Convention on Climate Change. So we concluded in the last assessment, surface temperature change is likely to exceed 1.5 degrees relative to the 1850 pre-industrial temperature. And you'll notice actually in this figure that the temperature for the low emission scenario, the temperature tends to level off very quickly. And what that's telling us is the surface of the ocean is coming into the surface of the Earth is coming into equilibrium quite quickly. Turns out that if you look at sea level, even for the low emission scenario, which is shown by here, that there's a continual increase, even though the surface temperature of the Earth has leveled off. So what this is telling us, there's a lot of sea level rise going on inside of the ocean through the ocean heat uptake and contributions from Antarctica and Greenland and ice sheets. And so we concluded that for all scenarios, mean sea level will continue to rise during the 21st century. And just to give you a sense of 1 metre of sea level change, 1 metre of sea level change, a relatively small change, can make a huge difference to what is happening. Take a return period. So this figure here is for a town in Tasmania, Georgetown in the northern part of Tasmania. The 1 in 100 year scenario is actually 1 in 100 year return period is actually becomes more frequent than every year for a high emission scenario. So what this really means is that the current return period, which is for the 1 in 100 year, by the end of the century is much more common than a 1 in 1 year. And even for a low emission scenario, a 1 in 100 year return period actually becomes a 1 in 3 year return period. So relatively small changes in particular places can actually have big consequences on the frequency of storm surges. There are other risks associated with sea level rise too. It's virtually certain that sea level will continue to rise, but new estimates from new papers since 2016 have actually shown the contribution for Antarctica could be as big as 15 metres for a high emission scenario by the year 2500. Now, I don't really trust these particular results, and there have been some new results that have come and which are reducing the total sea level rise for these high emission scenarios. But the point that I'm making here is that actually there is potential for big contributions from the two ice sheets, Antarctica and Greenland, which could have a profound impact and is definitely something we should be investing research money into. There are some critical thresholds too. Sea level's interesting because in the case of the 2 degree C pre-industrial temperature change, dangerous temperature defined by the United Nations Framework Convention on Climate Change, in the case of Greenland, in this IPCC report, if you exceeded 2 degrees, which is shown here, this is an equilibrium response, for temperatures less than 1 degree, we're currently at 0.8 degrees, sea level rise is relatively small contribution from Greenland. And then there's a kind of very high sea level rise for temperatures bigger than 2 degrees. So what this means is that we're right in the range for flipping between low sea level contribution from Greenland to a high sea level contribution from Greenland in this particular simulation. So it just points to a particular risk we have, and we're right in the zone from a policy perspective because of these are the sorts of temperature changes we're expecting to see. So for sea level, 2 degree threshold may actually be too high. Now, I've kind of given you a narrative here around the physical system, the emergence of human influence in the oceans and also atmosphere, and there are some risks I've pointed to in terms of Antarctica and Greenland. But ecosystems also have significant risks attached to them too. And it turns out in the fisheries research community, there are models for actually assessing fish stocks, and they can be tied to the CMIP, the temperature projections that are expected for future climate change for a low or high emission scenario. And we can project the changes in fish stock. In this case, this is the change in fish stock relative to the 2.5 to 2.6 degree, 2.6 low emissions scenario. So this is the difference between a high emission scenario and a low scenario. And so the equatorial area, you can see, is actually preferentially affected by the high emission scenario over the low emission scenario, particularly in the equatorial area with declines in the maximum catch potential of order 30 to 35%. And in the case of the maximum revenue potential of order, it's actually higher, greater than 35%. And the reason the maximum revenue potential is actually higher than the maximum catch potential is because these models understand the composition of the fish stocks, and the tendency is for high value fish, which are also the larger fish, are preferentially selected against. And as a consequence, by 2050, not so far in the future, those fish stock sizes will have preferentially gone to smaller fish stock. Not only can we understand the changes in the composition of fish stocks across the world, and we can see that the equatorial band is preferentially negatively affected, but the high polar regions tend to be positively affected. But we can also trace what this means. So there's a substantial fraction of the human population in the world that actually depends on nutrients and protein from these fish stocks, and they also depend on micronutrients, omega-3s, fatty acids and zinc, and those nations tend to also sit in this space here. And so as a consequence, and particularly in our report, we're tracking the changes in the physical system on to fish stocks and key ecosystems down to human communities as well. Now, all of this can actually, has attempted to be costed up, and there are basically economic stresses implied by these changes from climate change. And in the case of the small island developing states, so in the Pacific region, so the Vanuatu, the Tonga, Fiji, etc., there have been estimates made of the impact of climate change on those small island economies. And what you can see here is that the world average cost as a fraction of GDP is about 0.5%. And then everywhere else for each of these countries for where this analysis was undertaken is significantly higher than the world average. On average, it's 4 times higher in terms of GDP, with the worst being Vanuatu at 14 times. These are non-trivial costs, and in fact, there are estimates of what it would take to repair and adapt to these climate change signals on these small island developing states. It's not all bad news, because actually one of the nice outcomes that came out of the Hurricane Sandy, which impacted New York so strongly, was the efforts by Michael Bloomberg and Mark Carney to actually develop up a task force for climate-related financial disclosures. So what the purpose of this report was to actually make sure that companies, public companies, reported accurately on their climate-related risks. And as a consequence, they're trying to increase the transparency and risk to market institutions by correctly assessing climate impacts. So let me just finish off with the last slide. What we have, if I can put the narrative to you, and it's pretty much sort of the narrative that will come out of the special report on oceans and cryosphere, is that the climate's already changed, and those causes are by human influence. We clearly need, because of substantial risks, particularly around ice sheets, in my view, we need stronger mitigation measures to actually reduce the risk of excessive sea level change, particularly in the long-term future. It's clear, actually, that even relatively small temperature changes, relatively small sea level rises, relatively small temperature changes in the equatorial zone have really quite significant impacts on some of the key fish stocks, key ecosystems, and so we have actually committed to adapting to climate change. And this has to be more correctly incorporated into our governance structures around climate change. Climate change is clearly causing economic stresses for our coastal communities. Our risk assessments are incomplete, but in many ways, and I remain optimistic, it's a soluble problem. And that solubility is actually, which is a lousy pun, by the way, is actually reflected in the IPCC special report on 1.5 degrees. That shows pathways that are feasible and practicable, but not without considerable effort, to actually mitigating to 1.5 degrees temperature. And you can also see across governments and also business an increased awareness and increased need for disclosure. Thank you very much.
Fantastic. Thanks, Nathan. Thanks for that great overview. We do have a couple of questions, and I just encourage everyone to keep rolling the questions in, because we do have around about 10-15 minutes left for questions. So I'll just start with the first one, Nathan. And this comes from John, who says, "Hi Nathan, thank you for your effort. Interesting and worrying, to be honest. Given the fact that the world population will continue to rise at an even faster pace, what could that mean for this report and the observations mentioned?"
Yeah, so in these scenarios of future greenhouse gases, some aspects of that rising population, increasing use of resources for emissions has actually been taken into account. So we typically, how do I put it? These projections aren't naive in the sense that they have not taken population growth into account. So in a way, to some extent, those projections that I've shown you have a population component to them. And that was true in the special emission scenarios that we used in the third assessment reports. And in the SR 1.5, those resource uses, to some extent, was also taken into account. So it's a sort of a partial answer to your question, but some effort has been taken into account to understand that population-driven component.
Okay. We also have a question from Dave as well. He says, really useful slides, especially the timeline of the IPCC process since 1988. Would you be able to share those with us?
Sure, no problem. They're official IPCC slides, so I can't see any reason why not.
Excellent. I can make sure that we get those to you, Dave. And then we have one from David Caroli as well, saying, how much of the SPM, so the Summary for Policymakers, is deleted or not considered at the plenary meeting in order for it to be accepted by consensus at the meeting deadline?
So I've only been to 2 plenary sessions, and both have been for Working Group 1. That in every case, we have got all of the text accepted, and in every case, we've actually had the government's request, and you'll love this, the government's requested a figure, and we've added figures to those summary for policymakers to make them more complete. And the universal agreement of the Working Group 1 people has been that actually that 4-day interaction with governments has led to a better summary for policymakers than what we went in with. So it's a really positive thing.
Okay.
We haven't lost any words. And it came out better. That's the short answer.
Okay, and Grant's got a question too. He says, what work has been or is being done to understand climate system step change tipping points, and will these be reported on by the IPCC?
Yeah, so in the special report on oceans and cryosphere, in changing the SROC as we call it in short, we have a whole chapter around tipping points, points of inflection. You saw me illustrate an example, which was actually in the last report around Greenland, low amounts of contribution, high amounts of contribution. So there's actually a whole chapter in our current volume all about tipping points, the changing frequency of heat waves, the compound events where actually you get coincidence of a couple of negative events which actually have much more destructive power than just a single event by itself. All those things are actually in Chapter 6 of the special report. It's given serious consideration.
We have another question from Emma, who asks, what feedbacks were included and excluded in the forecasts? And if some were excluded, what impact would these have on the sensitivity of climate to CO2?
So this is sort of a big question, but actually in the coupled ocean atmosphere general circulation models, we have land surfaces and all the feedbacks that go with those. We have a full ocean circulation which interacts with the atmosphere, and the feedbacks that go with that are kind of included. But the major feedbacks that are not included or are, for instance, a realistic ice sheet over Greenland, over Antarctica and glaciers. So the feedbacks around the changing radiation budget, changing atmospheric circulation, increased melt and large sea level rise are not taken into account in the current state of the models. We do a little bit of a fudge to try and take it into account, but they're not properly considered, if I can put it that way. The question, the more important question from our perspective is actually a lot of those feedbacks may be not done properly. So this is the sensitivity. So there's a lot of discussion around doubling of CO2 and the sensitivity of the climate system to that. That includes a variety of feedbacks in it. And the question is whether they've got the right amplification to them or whether they're underplayed or overestimated. And it's those sort of over and underestimations which is probably the key to actually doing better going into the future. There's a couple other feedbacks that we don't take into account. We don't take into account the methane cycle. My experience is that won't be as big as you might first guess. We don't take into account some of the cloud feedbacks correctly. But mostly we do, and there's an evaluation of the models to make sure actually that we can describe the distribution of clouds correctly, the sensitivity is about right, the heat uptake in the oceans is right. And that evaluation is actually really important, and it's actually central to the detecting of human influence in the climate system too. So there are checks and balances checks and balances in the assessment process. We're fairly comprehensive, but there are the ones that we missed out.
And another question from Stacey, who asks, is there a similar critical threshold for the Antarctic ice sheet as for the Greenland ice sheet example?
Actually, I have to say all these questions are great. This one, and along with the last one, it's not clear that Antarctic ice sheet has the same sort of threshold as the Greenland ice sheet. In that simulation I showed you, for rising equilibrium temperature, the Antarctic ice sheet just steadily increased and added to sea level rise. So that's so it's an area of uncertainty, but my sense is that there are different sort of thresholds in the case of the Antarctic ice sheet, and there are part of that difference is whether there will be a rapid expansion of the, let me describe it correctly, with the right bottom bathymetry, it turns out that you can have unstable behaviour and you'll just continually lose mass. With the right bathymetry shape, you can pin the ice sheet and actually you can have stable behaviour. So they are thresholds, but for the whole of Antarctica, which is the sum of many critical ice sheet glacier streams, it may turn out that there's no particular threshold. There's an equivocatory answer if you ever wanted one. I hope that helps.
Fantastic. Well, that's all the questions that have come through for now. So I'll just thank everyone once again for attending, and thank you, Nathan, for giving a really great overview of the IPCC processes and what's coming up in the next report. Also give a little bit of a plug for next year. These Earth Systems and Climate Change Science webinars will continue in 2019, and the first webinar will be starting in February, and we'll be sending around some information about that one in the new year. But for now, thanks again. We hope you have a wonderful Christmas break, and we look forward to seeing you in the new year. So thank you.